This presentation summarizes the work we have performed on the in vivo evaluation of Sorrento bone graft strip. Two studies were performed. The first was the in vivo performance at 0, 6, and 12 weeks, and the second was a mechanistic point of view where the samples were evaluated at 3 and 6 weeks. Both incorporated a critical size cancellous defect model in skeletally mature New Zealand white rabbits. Sample size for the different study groups and time points is outlined in this slide. The test material was Sorrento strip hydrated with BMA, and Vitos foam strip was the predicate for the study. The samples were faxitroned prior to implantation to evaluate the structure. As you can see, the Sorrento strip has more open areas, which would hypothesize to allow more bony integration compared to the Vitos foam strip. Environmental electron microscopy was used to evaluate the materials prior to implantation. The box indicates the higher magnification on the right-hand side. The collagen sponge component of the material can be seen, as well as the calcium phosphate component, which has a degree of porosity as well to the surface. In the same manner, the Vitos foam strip was evaluated with an environmental scanning electron microscope. The collagen matrix and the TCP component can be seen in this image. You can clearly see the difference between the quality of the collagen sponge in the Sorrento strip compared to the Vitos foam strip. Bone marrow aspirate was harvested from the proximal tibia of the animal and used to immediately hydrate the materials. The Sorrento strip and the Vitos foam strip both hydrated well with the bone marrow aspirate, which facilitated implantation into the defects. 6 mm by 10 mm defects were created in the medial distal femoral condyle bilaterally in the adult skeletally mature New Zealand white rabbits. These defects were either filled with Sorrento strip hydrated with BMA or Vitos foam strip hydrated with BMA. Animals were additionally used for empty and autograft defects. The endpoints for Study 1 and 2 are outlined above. Study 2 incorporated the use of immunohistochemistry as well as paraffin histology. This allowed us a detailed examination of the defects. Macroscopic harvest and radiographic endpoints were of little value in this study. There were no adverse reactions detected in any material at any time point. Radiographic analysis demonstrated no adverse reactions to any material at any time point, but were of little value to assess the overall bone healing. Micro-CT at 3 weeks demonstrated evidence of new bone formation within the Sorrento strip as well as in the middle of the defect with this material, whilst the Vitos foam strip only had some new bone formation at the margins. Micro-CT continued to demonstrate a progression in healing at 6 weeks with the Sorrento strip, both at the margins and within the defect, whilst evidence of new bone formation in the middle of the defect was lacking with the Vitos foam strip. Similarly, at 12 weeks, a continued progression of new bone formation and remodeling was noted with the Sorrento strip, whilst little activity was noted for the Vitos foam strip at 12 weeks. Time 0 histology was processed. As can be seen in this slide, the Sorrento strip calcium phosphate component appears different compared to the Vitos foam strip. Paraffin histology is shown here at 3 weeks for Sorrento strip hydrated with BMA. New bone formation both at the defect margins as well as in the interior of the defect can be seen even at this early time point at 3 weeks. When viewed under higher magnification, it's apparent that abundant new bone formation both on and between the calcium phosphate component of the Sorrento strip, with lots of active osteoblasts on the surface producing new bone within the center of the defect. Examination at high magnification demonstrates the typical appearance of active osteoblasts on the surface as well as abundant new woven bone formation adjacent to the material. In contrast, the histology of Vitos foam strip plus BMA at 3 weeks demonstrated little evidence of new bone formation in the center of the defect. However, there was activity at the defect margins. A higher examination in the center of the defect demonstrates the lack of new bone formation as well as the presence of an overall inflammatory reaction, as well as some residual collagen, which is stained in red in this tetrachrome slide. Higher magnification again of the Vitas foam strip, demonstrating a lymphocytic infiltrate, as well as some residual material. The lack of new bone formation is noted. Histology was also processed with polymethyl methacrylate. This slide demonstrates typical results at 6 weeks with the defect outlined in yellow. There is evidence of abundant new bone formation with the Sorrento strip, while new bone formation is limited to the defect margins with the Vitas foam strip. 12-week PMMA histology demonstrated further evidence of bone remodeling and formation with the Sorrento strip, whilst the Vitas foam strip appeared to have little new bone formation at the 12-week time point. Histomorphometry was used to evaluate the amount of new bone formation as well as residual material, fibrous tissue, and marrow spaces using MATLAB. The histomorphometric results for mean new bone formation at 6 and 12 weeks is highlighted here, with Sorrento outperforming Vitas at both time points. Similarly, the resorption of the materials occurred in a similar fashion. Immunohistochemistry was used to examine the mechanistic aspects of this study. Alkaline phosphatase, cathepsin K, and IL-6 immunohistochemistry was performed to evaluate the in vivo response of the materials. ALP expression at 3 weeks was present in the center of the defect as well as the defect margins with Sorrento strip, whilst ALP expression was limited to the host bone margins with the Vitas foam strip, as shown in this figure. ALP activity for autograft in the defect at 3 weeks mirrored that of the Sorrento strip, with evidence of expression both within the defect as well as at the host bone margins. ALP activity at 6 weeks again was highly expressed with the Sorrento strip, both within the defect and at the host bone margins, consistent with the histological formation of abundant new bone. ALP expression at 6 weeks for Vitas foam strip was limited to areas where new bone was forming at the host margins. There was little to no activity within the center of the defect. Cathepsin K expression at 3 weeks for Sorrento strip was associated with the osteoclastic-like cells on the newly formed bone, whilst with the Vitas foam strip this was associated more with the residual material within the defect. Cathepsin K expression for the autograft group mirrored that of the Sorrento strip at 3 weeks, with expression on the cells on the newly formed bone as well as with the residual autograft material. At 6 weeks, cathepsin K expression was similar between the two materials, however with the noted lack of bone with the Vitas foam strip in the center of the defect. IL-6 was used as a marker of inflammatory response. As can be seen here, the lack of inflammatory response was noted with the Sorrento strip, while evidence of IL-6 expression is present with the Vitas foam strip. A similar pattern was observed at 6 weeks, where Sorrento had the lack of an inflammatory response compared to the Vitas foam strip. IL-6 expression for defects filled with autograft was similar to that of the Sorrento strip at both time points. The results of the mechanistic side of this work demonstrates clearly the anabolic response for the Sorrento strip when hydrated with bone marrow aspirate. The in vivo response was similar to that when the defects were filled with autograft. In contrast, the implantation of Vitas foam strip elicited a general inflammatory reaction and the lack of anabolic activity as noted by the lack of ALP expression.